Welcome. This is the last class for application of basic conditions of static equilibrium for the three standard cases. Concurrent force, all are coplanar, in coplanar, concurrent, general coplanar and parallel force system. Don't think equilibrium is over. Plenty of questions are pending, plenty of cases are pending, support reactions, all will come. But in systematic approach, see, sometimes they will give an object is placed on a rough surface, what is the normal reaction, that all will come later. In systematic approach, first we considered concurrent force system. Next, coplanar force system. Coplanar in general. Today, parallel force system. See, here unknowns are given for you. See, in all the questions, they told you unknown. Find, see this question. For the given force system, find P1 and P2 for equilibrium, that way. Later, unknowns will not be given. Unknowns you have to decide. At that time, you have to consider action and reaction. Reactions are unknown. Action means the applied loads. So, here, same question if you see this 300, 90 and 60, you can tell action. P1 and P2, you can call reaction at that time. But right now, systematic approach, we don't bother about those things. As soon as today's class is over, next I will tell you regarding different types of loads. Little huge class, not huge class, huge part. It may take around 6 to 7 hours for me. Maybe around 7-8 classes it may take. Or worst come worst, not worst come worst. Or if I cut short slightly, at least some 5-6 classes. That is types of loads. Then support reaction, very powerful in structural engineering. Then we will once again apply equilibrium. Okay, now, right here. Class number I forgot now. Part 2, I think lecture 8. Anyway, you see the title there. Application of basic conditions of static equilibrium to parallel force system. Class, first you are right. I will dictate. I told you, so many things I decided to dictate in the class. Whereas notes I will write that one. Class, parallel force system. There are only two basic conditions of static equilibrium. I told you, one of them is sigma F equal to 0. Other is sigma M equal to 0. Sigma M equal to 0. Algebraic sum of moment of the entire force system about any point equal to 0. Sigma F0 is, if all the forces are along y, it becomes sigma Fy0. See, in this question, all the forces are along y. So, I write sigma Fy0. See, I write here. Class, sigma F equal to 0, that is sigma Fy equal to 0. Reason. Next question, I will do one thing. For a change, I will give horizontal forces. Then I will, sigma Fy will not come. Sigma Fx will come 0. Suppose all forces are inclined. Then sigma F in that direction equal to 0. This all we covered earlier. Okay, start. Find the value of P1 and P2 for equilibrium. Now, two unknowns are there. Two conditions are there. So only two unknown possible. The two unknowns are either two forces. Okay, done. Either they can ask what to see this question, two forces, P1, P2. Or it can be only one force. But then there should be second unknown, it will be distance. Here they will tell you where is P1, where is P2. Next question also I will give not P1, P2, P. I will tell P or I will not tell P. A force is to be applied. You find that magnitude of the force with the direction and also where is it is to be applied. So unknown is here two force unknowns. Next question, one force unknown, one distance unknown, like coplanar. Instead of vertical, I will take horizontal forces at that time. Okay, start. Now very simple. See, I wrote the solution. I wrote a sketch once again. Sigma F0, that is sigma Fy0, upward positive. First unknown, plus P1 minus P2 minus 300 plus 90 minus 60 equals 0. you will get P1 minus P2 equal to take that side plus 270. Why? Take that side. Equation number 1. Sigma m about A0. See, class. Right now, it is sigma m about any point equal to 0. Any point, I will take about A. Little later, I will give information for you. So right now, A. Why A means, see, somebody will ask, sir, why A? Take any point. Don't ask me why. Take any point. Okay. Okay, moment about A. Unknown first. P1 into 5, anti-clockwise. P2 into 11, clockwise. 30 into 0, 90 into 3, anti-clockwise. 60 into 7.5, clockwise, equal to 0. Simplify, you will get minus 5P1 plus 11P2 equal to minus 180. Equation number 2. Solving 1 and 2, you get P1 and P2. Okay. Class something. So both came positive, means correct. Your P1 is like this and P2 is like this. Your P1 is vertically up and P2 is vertically down, because I told positive sign indicates what direction you considered the unknown is correct. It is not upward, downward. What direction it is considered is correct. Right, over. Now, come out. Note, after sigma fy equal to 0, see here, you get P1 minus P2 equal to 270, same as earlier. This is same as earlier. Same as earlier. Instead of sigma m about A0, it is better to consider sigma m about either C or E equal to 0. Why? I will tell now. Little later, I will tell more and more. See, if you take moment about A, see, P1, P2, both will come. One more equation will come. We already solved it. But if you take moment about C, P1 into 0. So directly you get P2. Instead of solving simultaneous equation, direct answer will come. Or if you take moment about E, then P2 into 0. See, right here, all this you write, then write. Later, when you go to support reaction, there he will tell, he means me. You write, he will tell more about this one. He will insist, when you apply sigma m0, always consider moment about a point where there are more unknowns. If more unknown, or at least where there is unknown. Take moment about a point where unknowns are there, so that moment of the unknown force at that point becomes 0. Or I will tell you, take moment about the point where unknowns are more. So every force unknown there will become 0. That moment will become 0. Okay, now, therefore, after this equation, instead of, see, now one thing, see there, cancel this one. Instead of this one, you take moment about C. Anything, either C or E. If you take about C, see now, you write here. See, P1 into 0, you should write it. P2 into 6, clockwise. 60 into 2.5, clockwise. Plus 90 into 2, clockwise. See, 90 into 2, clockwise. Minus 300 into 5 equal to 0. Directly you will get P2. I calculated, P2 came 195. See, same answer. Then substitute in equation 1, P1 minus P2 is 270. You get P1 equal to 465. Or write one more. Take moment about E. You should write, instead of sigma m about C, take moment about E. I will dictate for you. P1 into 6, clockwise, minus 300 into this full length, 11, anti-clockwise. 90 into 8. 90 into 8, clockwise. Minus 600 into 3.5 equal to 0. You will get P1 equal to, my guarantee, 465 kilonewton. Substitute in equation 1, P2 will come. P2 will come. P1 will come plus 465 kilonewton. Substitute in the equation 1, P2 will come 195 kilonewton. Okay, now last question of this application of basic conditions of static equilibrium for coplanar force system. First one is concurrent, general coplanar and parallel in systematic order when unknowns are given by them. Next we will go to some other part. Okay, I will prepare next question, then I will solve it. Second question and closing question of this part. For the given parallel force system, question is a force P is to be applied to get state of equilibrium, or equilibrium is to be maintained. They are telling a force P is to be applied. Now they are asking find the value of P and also where it is to be applied. Means two unknowns. One, how much is the value of P? Second unknown, where it is to be applied means distance. Okay, start. Force system is given here. Little ink got faded here. I hope it is visible. Manage today. Usually I write with a dark color. Okay, leave it now. Solution, x, x, y, y. Now, for equilibrium, see they are not given whether P is right side or left side. You should decide it. Actually, people can decide by looking only, they will tell. See, 100, 80, 60. 100 plus 80 plus 60 is 240. 70 plus 120 is how much? 190. 240 right side, 190 left side means unbalance of 50 to right side. So for equilibrium, force should be 50 to left side. Common sense is sufficient to get that answer. Still, we will do systematically, right? Since it is not given how is the force P, we will do one thing. For this given force system, don't see there, find sigma fx. It is not 0 because no equilibrium. See, right now no equilibrium. Equilibrium is only after you apply P. Sigma fx. If I take right side, plus 100, minus 120, plus 80, minus 70, plus 60, it is plus 50 Newton. So for the given force system, net force acting is 50 Newton to right side. Therefore, if you want equilibrium, sigma fx should be 0. So for equilibrium, see, sigma fx should be 0. So when this is 50 Newton right side, the force P should be 50 Newton to left side. See, 50 Newton. Now see now if you apply sigma fx equal to 0, plus 100, minus 120, plus 80, minus 70, plus 60, minus 50. But don't apply. Over. Now value of P came. So the force P should be 50 Newton to be applied to left side. But where to be applied? We have no idea. Who knows? It may be within the two outermost forces, or it can be above this force. It can be below this force. We don't know. Depends upon the moment. Therefore, you assume, let the force P be applied at y, see, at a distance of, not y, x actually, y, because vertical distance, actually take x only, I actually told y there, then wrote x here, okay. Distance y, okay. Y, no problem. This is not a big issue. How much I got? 6.4. Correct, huh? Forgot it now, see. Forgot it. I have to calculate once again now. I forgot it. See. Let the force P be applied at distance y from line of action of 60 Newton force. Reference, we will take this reference. Let it be at y above that force. Okay. Now, your choice. You can take wherever you want. You can refer from top also. See, even you can take y from here also. But that I will tell you later. On me now. See, answer. But we don't know. Don't see here. See, somewhere at y, it can be between these two, can go above or can come below. Now, apply sigma m equal to 0. Algebraic sum of moment about any point in the line of action of 60. See, some point. So in this line, take a point A. take moment about A, which lies in this line of action. Start. Minus P into Y, P equal to 50 Newton, minus P into Y, minus 70 into 2, plus 80 into 5, minus 120 into 7, plus 100 into 9 equal to 0, you get the value of Y. I'll check once again. I got doubt now because I rubbed it. Minus 70 into 2, plus 80 into 5, minus 120 into 7, plus 100 into 9, divided by 50. 6.4 meter. Yes, it is 6.4 meter. Very important. Very, very important. Get the answer. Answer with sign. With sign. Now, I will dictate something in the class, you are right. Y came plus 6.4 Newton. We assumed the line of action of P to be above the point A by Y. It came plus, so correct. It is really above this point. By how much? By 6.4. Therefore, you can do one thing. Come back to the sketch once again and mark the force here. 6.4 means 2 plus 3, 5. 5 means, okay, this I can remove now, correct? I want that one. So, okay. 2 plus 3, 5. See, the force P is to be applied somewhere here. You can write one more sketch. Force P equal to 50 Newton. You should apply it at, where I should show it here. I'll do one thing. 70, I will put little this side. 70 Newton without disturbing. See, by 6.4 meter is the answer. Now make a note. By chance your Y comes 9 point something. It can come sometimes. See, for example, 9.8 it comes. Imagination. Then answer is, see, if it comes to 9.8, see. You should make a note. 70, 60, 9.8. See, from here to here is 9 meter. Correct? 9 point plus only comes. So 9.8 means your P should be applied somewhere here. At what distance? At 9.8 meter here, or 0.8 meter above the uppermost force. Make a note, or right here. Suppose your Y comes, just imagination, if your Y comes, only understanding purpose, minus 3.6 meter. Then what it means? We took Y above, negative came. So Y is not above, it is below. That means your P will be not here. It is not here. Write one more sketch if you want. From this point, see, from this point A, you should apply how much? 3.6 meter below. Below 3.6 meter. Over. Make a note. Now, one homework for you. I took Y from here. Do one thing. Now, make a you extend the question. Same way right here. You write Y from line of action of not 60, line of action of 100 Newton force. That is, instead of here, you take it here. Below here, Y. My guarantee, 100% your Y will come, because if this is 6.4, total 9, this will be 2.6 meter. My guarantee, Y will come plus 2.6 meter. Otherwise, we will close the class. Okay, then right here, take moment about this point. See, 100 into 0, 120 into 2, clockwise, 80 into 4, anti-clockwise, 70 into 7 clockwise minus 60 into 9 plus 50 p50 into y. Solve it. My guarantee y will come 2.6 meter, because whether you take moment about point here or this point or here or here or here or here or here or here or here, whichever point in the plane you take moment, result will not change. The basic is algebraic sum of moment of the entire force system about any point. Okay, now one brain teaser question is pending, that is regarding sigma m0 applied 2 times, where sigma you apply sigma m0 twice and we did not apply sigma what v0 earlier. I very fast I will extend that question. Okay, now over. Now next class will be the most critical part of our subject, that is different, most probably I decided different types of load. See, in the part 2 I wrote, or I may do for some other equilibrium question for contact surface. Anyway, I will decide when I take next class. Depends. If I am feeling too tired because of other classes, I may take some examples. If I am feeling fresh, because to explain different type of loads, more energy required. Lot of things are there to explain. Point load, UDL, UVL, etc. But anyway, if not now, little later, everything will be covered. So I will decide by that time. But you study everything. If you want to learn complete base subject, everything should be studied. Don't ignore anything. Thank you.